Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rifaie Ramli, and today I would like to present my mini project under MEC 351, which is refrigeration and air conditioning system. The first one, I will explain my introduction. Uh, as you know, in this century of full of technology, we are provided to many facility. I will give some example. So in this century, we have a car that makes us easier to travel for a long distance. So in the ventilation system or ventilation system, uh, we have air conditioning system that make human comfort. The desirable conditioner may be temperature, humidity, dust particle level, and air motion. Me as a HVAC engineer, I was assigned to build an air conditioning system in one building, which is a private office that located in Petali Jaya, Selangor. The name of the building is MCOP Group. So the methodology I use for this um, ducting is the first one. I I make some calculation because before I make a ducting system or I create a ducting, so I make some calculation based on cooling load estimation. So in this building is provided is provide 7 room, which is office 1, office 2, office 3, office 4, reception, conference room, and breakpoints room. And then me and the others 7 HVAC engineer calculated the BTU per hour for each room, and this is the result. Yes, after getting the all the rooms in the building, the next step is to calculate the throw radius of the diffuser. The way to calculate is through this formula. As you can see, for length side, one throw is equal to room length dimension is divided to Notch number. Okay, for the information, one Notch number is equal to one diffuser is equal to two Notch number. So that for example, if in one room has a one diffuser, so the room length dimension will divided by 2. Same also with side. One throw is equal to room with dimension and divided by Notch number. The formula is used is clearly related to the area of room because we were assigned to make an air conditioning system for the whole building. There must be many rooms in that building, for each room area is not the same. The way to calculate the throw radius for each room is to calculate the average length and width for of room as the formula given. So this is the table that we already calculated, and we compile it into one table. As you can see, this is the section of each ducting. This is the CFM that CFM that we 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 give or that provide from the diffuser, because the one diffuser provide 100 CFM. This is HF per 100 because why the number is 0.14, because we use a galvanized steel. So this is the duct length that we already calculate or we measured on the paper. This is the dimension of duct that we get from the galvanized steel. This is side of rectangular, also we get from the galvanized steel, also the FPM. Then and this is the pressure drop. The formula of pressure drop is HF per over 100 multiply with duct length, and then we get the result and we put in the table. So this is the procedure that I make myself to calculate to create the ducting length. So the first one, I observe the area. I observe for the whole building. I observe the each room. After that, I calculate the cooling load using cooling load table estimation that I mentioned already before. After that, I calculate the CFM for each room using the cooling load estimation, and then I total all the value of BTU per hour uh, and then I calculate the throw radius using the formula that I mentioned before, and then I determine the suitable diffuser for each room based on value of CFM, and then I created the table for duct length, diameter of ducting, FPM, and more. After that, I determine the fit position to place the diffuser in each room, and then I identify the suitable air conditioner system for that building, and then I design a ducting and diffuser using AutoCAD software, and after that I built the ducting in that building. The next one, after I create or I use the calculation, I make an assumption to design a requirement. In this slide, I already state for each room for with dimension, capacity, equipment, and building material. For this is for the office one, as you can see in this slide. This is for office 2, this is for office 3, this is for office 4, this is for conference room, this is for reception area, and the last one is the build area, a break area. After that, after I make a methodology, I continue for the calculation. Okay, the first one for the calculation is sample calculation of analysis of CFM. As you can see from the table that given in the slide, this is the value of CFM from the each room. For example, for the example, office 1 has a 32.5 value of CFM. Same also for office 2 and office 4, because they has a same value of dimension. This is of a conference room, the area, and the reception area. The next one, calculate the throw radius that I already mentioned before. How to find it? One throw equal to room length or width, and divided by Knox number. So this is the table for um, a throw radius for each room. So this is for office 1, office 2, office 3, office 4, conference room, breakpoint, and reception area. So the dimension of duct FPM and side of ducting, I get it from this galvanized steel chart, as you can see in this slide. And then I use the cooling load estimation. This is the one of the cooling load estimation that I choose, which is this. This is the cooling load estimation for office 1. Lastly, for result and discussion, this is the table that I calculate for the CFM, throw radius, and cooling load. So after we calculate before for the CFM, throw radius, and cooling load, we compile it, or we collect the data and we make a table to put it all the value in that table. For the diffuser and air conditioner system selection, for diffuser selection, we have some research and observations through the several brochure. We agree and decided to choose a SFD type diffuser, because the size of the diffuser is round and the diameter of the diffuser is 200 mm. This diffuser is capable of accommodating CFM and area from 18 to 100. So the reason we choose this type is because the most room in this building has CFM not exceed than 100, except conference room, which has CFM value is 125. Only conference room we put 2 diffuser, because this diffuser only can only accommodate the CFM to 100 only. So that's why we put 2 diffuser in this room. For the air conditioner system, we agree that use indirect expansion, that is refrigerant cycle work, and indirectly to absorb the heat from the refrigerated space and release the heat to the environment. This system is better known as a chiller water system. Chiller water works as refrigerant to absorb the heat. Heat were absorbed by a refrigerant cycle to the evaporator. For this building is a private office. That's why we choose indirect system. because in this indirect system they have a water cool chiller, a cool water chiller, because the BTU for this building that I already calculated is uh 104,773.42 BTU per hour, and the for air cooled chiller can accommodate from 80,000 to 138,000 BTU per hour. So this is the most suitable chiller that I can use for this building. So this is the some image of the water cool air cool chiller air cool chiller. So this is our AutoCAD design before we build the ducting system. So as you can see, the purple one is for the ASU, and then this the ducting diffuser, as you can see in this slide. Okay, that's all from me. Thank you and assalamualaikum.